It is the middle of the Pacific Ocean, and a machine is coming home. For 2 days, it has been sitting in total darkness, 4 kilometers straight down, on a part of the seafloor that almost no human being has ever seen. Now, it is rising back toward the light, and on board the ship, a small group of scientists is leaning over a screen, waiting to read what it recorded. There is a line on that screen, a simple line that tracks one thing: how much oxygen was inside the machine while it sat on the bottom of the world. And the line is wrong. It isn't falling. Down there, in the cold and the dark, where it should have been dropping hour after hour, the oxygen is climbing. The first thought in the room is not wonder. It is something much more ordinary. Someone says, almost certainly, the words that have ended 1,000 experiments before this one. The sensor must be broken, so they check it. And that is where this story actually begins. Here is something strange about the planet you live on. We have mapped the surface of Mars. We have photographed the cloud tops of distant worlds and traced the rings of Saturn. And yet, the floor of our own ocean, the largest single feature on Earth, remains, for the most part, a blank. Over 80% of ocean has never been explored. As of early 2026, only about 29% of the seafloor had been mapped in real detail, using the kind of high-resolution sonar that actually shows you the shape of the ground. The rest is a guess drawn from space. Even that guess is a recent gift. We can now read the shape of the hidden seafloor from orbit using satellites that measure the faint bumps and dips in the surface of the sea caused by the gravity of mountains and valleys far below the water. And mapping is the easy part. Mapping just tells you the shape of a thing. Actually going down to look at it is something else entirely. By the most careful estimates, human beings have laid eyes on less than 1/1000% of the deep ocean floor, an area about the size of the state of Rhode Island. That is how much of the deep sea we have actually seen. Everything else is dark. Now, the deepest, strangest parts of that dark have a name. Scientists call them the Hadal Zone. These are the trenches and troughs that plunge as far as 11 kilometers below the waves, and stacked together, they would cover an area the size of Australia. Almost nothing built by humans can survive down there. The pressure alone is enough to crush most things we send into it. But the place where our story happens is not the very deepest part of the ocean. It is somewhere stranger, because it looks, at first, almost ordinary. It is a vast, flat plain on the floor of the eastern Pacific, stretching roughly 4,500 miles between Hawaii and Mexico. Scientists call it the Clarion-Clipperton Zone. About 4 kilometers of black water sit on top of it, 13,000 feet of crushing cold. No light reaches it. No plant has ever grown there. And scattered across that plain, like a field of dark potatoes, are billions of small metallic lumps. They are called polymetallic nodules. Each one is a slow accident of chemistry, built up over millions of years, packed with the metals that run the modern world. Cobalt, nickel, copper, lithium, the same metals we put inside batteries and solar panels and phones, and they are old, almost unimaginably old. Each nodule grows by pulling metal out of the seawater around it, one microscopic layer at a time, over millions of years. A single lump, no bigger than a potato, may have taken 10 million years to form. They lie on the mud, in their billions, untouched, in a place where nothing moves quickly and almost nothing happens at all, which is part of what made what came next so jarring. Because on a seafloor, where time itself seems to crawl, something appeared to be busy. And it is one man, watching that wrong line on that screen, who decided not to look away from them. His name is Andrew Sweetman. He is a British marine ecologist, a man who has spent his career sending instruments down into the deepest, quietest places on Earth and reading what they bring back. And the thing about Sweetman is that he had seen this strange signal before, years earlier, and he had done exactly what every careful scientist is trained to do. He had assumed his equipment was lying to him. He had recalibrated the sensors. He had sent them back down, and the ocean did it again. That is the human heart of this whole story. Not a discovery, A decision. The decision to believe a reading that contradicted everything in the textbook and to keep believing it long after it would have been easier and safer to call it a glitch and move on. To understand why that line on the screen was so unsettling, you have to understand the machine that drew it. It is called a benthic chamber lander. The idea behind it is simple and old. You take a box, you lower it all the way to the seafloor, and you press it gently down into the mud so that it traps a small sealed pocket of the bottom, a little square of sediment, a few nodules, and the cold seawater sitting on top of them. Then you wait. Inside the box, sensors measure the oxygen in that trapped water, taking a reading every 10 seconds, for hours, for decades. These machines have always told the same story. The oxygen always goes down. That makes sense, because the deep sea is hungry. It is full of tiny organisms living in the sediment, and like nearly all life, they breathe. They take oxygen out of the water, and they consume it. So every time one of these chambers sealed off a patch of the seafloor, the oxygen inside it would slowly, steadily fall as the living things in the mud quietly used it up. Study after study, the line went down. There was nothing controversial about that. It was one of the most reliable measurements in all of deep-sea science. You lowered the box, you sealed the bottom, you watched the oxygen fall, and you went home. The very rate at which it fell told you how much hidden life was breathing in the mud below. The falling line was not a surprise. It was the entire point. It was how the instrument was supposed to behave. Until, in the Clarion-Clipperton Zone, it went up. And now here is the fact that should make you stop. Down there, 13,000 feet beneath the surface, in water so dark that no ray of sunlight has touched it in the entire history of the planet, something appeared to be making oxygen. Sit with that for a moment, because it cuts against something you were taught so early you probably never questioned it. Every breath you have ever taken traces back to light. Oxygen, on Earth, comes from photosynthesis. Plants do it, algae do it, microscopic ocean bacteria do it. They take sunlight and water, and they release oxygen as the byproduct. That single process is the reason this planet has a breathable sky at all. No sunlight, no photosynthesis, no oxygen. That is the rule. And here was a place with no sunlight, and the oxygen was going up. If that reading were real, if it were truly the seafloor making oxygen in the dark, then it would mean there was another way, a second source. A path to producing the most important molecule for complex life that did not need the sun at all. That is not a small adjustment to the textbook. That is a crack in the foundation. For as long as we have understood where oxygen comes from, we have told the same story about ourselves. That complex oxygen-breathing life could only have arisen after tiny photosynthesizing organisms spent hundreds of millions of years slowly filling the sky with the gas. Light came first, then oxygen, then us. That is the order of events we have always assumed, and a seafloor quietly making oxygen in the dark would suggest that the order might not be the only one possible, that somewhere, maybe here, maybe on a world we have never seen, life might have had a second door to walk through. And it raised a question that reached far past this one muddy plain in the Pacific. If oxygen can be made in the cold and the dark, with no light and no living thing required, then the list of places where life might survive in this universe suddenly gets a great deal longer. So the team gave the discovery a name. They borrowed a phrase that had been used before for oxygen made without sunlight, and they called it dark oxygen. And then they had to answer the obvious question. If the sun wasn't making it, what was? The team's eyes landed on the nodules. It was a reasonable suspicion. When they ran the experiment in the lab without the nodules, the strange oxygen seemed to fade. When the nodules were there, it appeared. So whatever was happening, the metal lumps seemed to be at the center of it. But suspicion is not a mechanism. To convince anyone, they needed to explain how a cold rock on the seafloor could possibly conjure oxygen out of seawater. And the explanation they reached for is, in a way, Beautifully simple. Think about rust. When iron rusts in the presence of salt water, it does something quietly remarkable. It generates a tiny electric current. The rust and the salt water together behave like the inside of a battery. And the team wondered whether these nodules, packed with metals, sitting forever in the most natural salt water on Earth, might be doing the same thing on their own. So they brought nodules into the lab, and they touched fine probes to their surfaces, and they measured the voltage, and they found something. A single nodule, they reported, could carry a charge of close to 1 volt, about the same as a small household battery. Cluster enough of them together, they argued, and you might have real electrical power sitting on the ocean floor. And electricity, in salt water, can do a very specific and very famous thing. It can split water. This is the process called electrolysis, and it is one of the cleanest reactions in all of chemistry. Run an electric current through water, and you tear each water molecule apart into the 2 things it is made of, hydrogen and oxygen. The hydrogen bubbles off one way, the oxygen bubbles off the other. It is the same reaction we use up here on the surface to make clean hydrogen fuel. Run a wire from a battery into a glass of salty water, and you can watch it happen with your own eyes. Fine bubbles streaming up off the metal, the water slowly taking itself apart. The only thing it has ever needed is a push of electricity strong enough to do the work. So the theory came together like a key turning in a lock. The nodules, the team proposed, were natural batteries. Geo-batteries, they called them. Sitting in the dark, generating their own faint current, slowly splitting seawater and releasing oxygen into the black. No sunlight, no life, just chemistry and metal and time. They had measured voltages on the nodule surfaces reaching as high as roughly 9/10 of a volt, and to them, that was the smoking gun. Now, and hold on to this, quietly, because it will matter later, there is a number that splitting water actually requires. To pull a water molecule apart, you need to push a little more than 1¼ volts through it. That's the threshold. Below it, the water simply will not come apart. And the voltage the nodules seemed to offer sat just underneath that line. There was one more thing, too. When you split water, you don't only get oxygen, you always get hydrogen alongside it, in a fixed and unbreakable ratio. 2 parts hydrogen for every 1 part oxygen. Always. So if the nodules were truly splitting seawater, there should have been hydrogen pouring off them as well. No one reported catching any, but let that sit for now. In the moment, none of it slowed the story down, because the implications were simply too large. And this is where a second organization quietly enters the picture, one you might not expect to find at the bottom of the ocean. NASA. For years, NASA has been sending machines into the deep sea, not as a side project, but as a rehearsal. Because the bottom of our ocean is the closest thing on this planet to the oceans NASA believes are hiding elsewhere in our solar system. Far out, circling Jupiter, there is a moon called Europa. Beneath its cracked shell of ice lies a saltwater ocean thought to hold twice as much water as every ocean on Earth combined. Around Saturn, the moon Enceladus jets plumes of water vapor into space from a hidden sea below its crust. These are the ocean worlds, and they are, right now, among the most promising places we know of to look for life beyond Earth. The problem is that no sunlight reaches those buried oceans, and so, for a long time, they were easy to dismiss. Life needs energy. Energy we assumed traces back to the sun. A lightless ocean under miles of ice seemed like a dead end, but the deep sea taught us otherwise. In 1977, a research team lowered a vehicle 8,000 feet into the Pacific to photograph hydrothermal vents, places where heat from inside the Earth leaks out through the sea floor. What they found astonished them. Whole ecosystems crowded with strange creatures thriving in total darkness around those vents, animals that did not depend on sunlight at all. They lived off the chemistry seeping up from the rock beneath them. That single discovery rewrote the rules of where life could exist. And it is exactly why NASA started going to the bottom of the ocean. The creatures around those vents had solved a problem that should have been impossible. Down there, the pressure can reach 15,000 pounds on every square inch. Enough, scientists will tell you, to squeeze the individual cells of an animal right out of its body. And yet the life holds together. It does so by growing special molecules that prop its proteins open against the crushing weight, like tent poles holding a tent up in a storm. Some of these animals live miles down, in water barely above freezing, right beside vents where the temperature can climb past 370 degrees. And they do it all without a single ray of sunlight. They feed on the chemistry leaking out of the rock. To NASA, that is not just biology. It is a preview, because the buried oceans of Europa and Enceladus may work in exactly the same way, dark, pressurized, and lit only by the heat and chemistry seeping up from the seafloor. So the agency built a program around a simple, almost poetic idea. If you want to learn how to explore an ocean on another world, you should first learn to explore the one at the bottom of your own. Its scientists sent remotely operated vehicles down to underwater volcanoes off the coast of Hawaii and off the stretch of sea where California meets Oregon, studying the warm springs there precisely because they may resemble the seafloors of those distant moons. They practiced running the missions the way they would one day have to be run across space with the science team far away, the commands delayed, the robots forced to make decisions on their own. And they kept building stranger machines. One earlier vehicle, sent down into a deep Pacific trench more than a decade ago, was lost entirely. It imploded under the pressure, miles below the surface, and came back up hours later as small pieces drifting on the water. The team rebuilt. Their newer Explorer is smaller, lighter, about the size and weight of a quad bike, and it finds its way across the sea floor using the same kind of visual navigation that guides a rover across Mars, recognizing rocks and ridges to remember where it has already been. Part of its body is made from leftover flotation foam, salvaged from the submersible that once carried a film director all the way down to the deepest point in the entire ocean. They have even drawn up the most science fiction idea of all. Swarms of tiny swimming robots, each one no bigger than a juice box, dozens of them released at once, meant one day to be poured into the water beneath the ice of another world, to spread out and to hunt together for the faint chemical fingerprints of life. So when a research team announced that they had found oxygen being made in the cold and the dark at the bottom of our own ocean, NASA was, by the team's own account, paying attention. The lead scientist said they were already in conversation with experts at the agency, experts who believed that if oxygen really could be produced without sunlight, it might reshape our entire understanding of how life could be sustained on cold, dark worlds far from any star. That is how big this claim was. It did not stay on the sea floor, it rose all the way up into the question of whether we are alone. And that is precisely why what happened next mattered so much. The discovery was published in the summer of 2024 in a respected scientific journal, and it did not stay quiet. It became one of the most read papers the journal had ever run. It spread across the news, it spread across social media. It landed in the middle of a fierce, ongoing fight over whether companies should be allowed to mine those metal nodules from the seafloor, because if the nodules were quietly keeping the deep sea alive with oxygen, then scooping them up by the millions suddenly looked like a very dangerous idea. The finding climbed into the rarest tier of scientific influence, the small handful of studies the wider world actually argues about. And the stakes were not abstract. Across that one stretch of Pacific seafloor, more than a dozen companies already hold claims to mine those nodules. The metals locked inside them, the cobalt, the nickel, the copper, the manganese, are the same metals the world is racing to pour into electric car batteries, and there are thought to be enough nodules down there to feed that demand for decades. So the question of whether these lumps were also quietly breathing oxygen into the deep sea was never going to stay a calm laboratory matter. It sat directly on top of a decision worth a fortune, whether to start tearing them off the seafloor at all. And then the scrutiny came, and the story began to come apart. The first crack was the most damaging and the simplest to understand. Some of the experiments that recorded rising oxygen had not contained any nodules at all. This was the entire theory's foundation. The whole idea rested on the nodules being the source, the batteries, the engines of the dark oxygen. But when other scientists went back through the records, they found earlier deployments made years before the headlines where the chambers had come up holding rising oxygen and no nodules inside them. Just sediment, just seawater. In some cases, only fine dark grains of manganese oxide, the kind of common material scattered across deep-sea mud almost everywhere. If the oxygen could rise without the nodules, then the nodules could not be the thing making it. And it got worse. On at least one occasion, the lander had been lowered to just above the seafloor. Its doors closed early so that it sealed nothing but a box of plain seawater, no sediment, no nodules, nothing. A clean control. The kind of test that is supposed to prove your instrument behaves itself when there's nothing there to react. In 2 of those 3 empty chambers, the oxygen rose anyway. That is the result that turned the whole story inside out. Because oxygen climbing inside a box that contained nothing but water doesn't point to a miracle on the seafloor, it points to the box. It suggests the machine itself, not the ocean, not the nodules, was the source of the signal. And here is the part that gave the controversy its sharpest edge. That empty chamber control, the one that undercut the entire claim, was not included in the published paper. The data that contradicted the discovery was left out of the story of the discovery. That single absence is what transformed this from a scientific disagreement into something closer to an accusation. Critics argued that important results pointing the other way had been omitted, set aside, unmentioned, while the results that supported dark oxygen were placed in the spotlight. Some went as far as to call it a form of data falsification, not inventing false numbers, but quietly leaving out the true ones that didn't fit. That is the quiet center of this entire story, and it is the part that should stay with you. A discovery is not only what you find, it is also what you choose to show. The same line that climbed inside a box full of nodules also climbed inside a box that held nothing at all, and only one of those 2 facts made it onto the page. Whether that was a deliberate decision or an honest oversight is something only the people in that room can truly know, but the effect was identical. For a while, the world was told a cleaner, stranger, more wonderful version of events than the data ever actually supported. Now, when a controversy reaches this point, it usually generates a long chain of rebuttals, each one piling on. This one did, but they don't all need equal weight, because most of them circle back to the same few wounds. The deepest was the one we already touched, the voltage. Remember, the threshold splitting water needs a little more than 1¼ volts. The team had pointed to a peak reading of about 9/10 of a volt as their evidence. But critics, looking at the paper's own main figure, found that the highest value actually plotted there was closer to 1/4 volt, and the average of all the readings, across all the nodules, came out to something around 2/100 of a volt. A whisper of charge, nowhere near enough to tear a single water molecule apart, let alone enough to flood a sealed chamber with oxygen. So the strongest number in the headline, the 9/10 of a volt, appeared to be an outlier, an extreme high point, lifted out of a dataset whose ordinary readings were a tiny fraction of that. And even that outlier still fell short of the line. The other objections followed the same quiet pattern, and we don't need to dwell on each in turn. There was the hydrogen that should have appeared alongside the oxygen, and never did. There was the matter of simple physics that splitting water doesn't happen for free, that it requires energy pushed uphill, and the geo-battery theory never identified where that energy was supposed to come from. There was even the inconvenient fact that in seawater, an electric current would much rather rip apart the salt than the water, producing chlorine long before it produced oxygen. Each one, on its own, was a serious problem. Together, they pointed in a single direction, and then came the most telling response of all. The company that had paid for the original research, a deep-sea mining firm hoping to harvest those very nodules, turned around and publicly attacked the study it had funded. Its leaders repeated an old scientific principle like a closing argument: extraordinary claims require extraordinary evidence, and they said they were still waiting for it. Under all of that weight, the discovery began to retreat. The original authors themselves quietly stepped back from both of their headline claims. They stopped insisting it had to be the nodules specifically, shifting their language to manganese oxides in general, the common stuff of the seafloor. And they let go of electrolysis as the mechanism, conceding that it was, in their own later words, presently unclear what was actually causing the effect. Then, in the spring of 2026, the journal itself stepped in. On the 8th of April, the editors attached a formal note to the paper, alerting readers that aspects of the work were now under question and that the matter was being reviewed. The discovery that had reached all the way up toward the question of alien life was now flagged, contested, and walking back its own conclusions. To understand just how far this one result stood out, you have to set it next to everything that came before it. Because scientists had measured the breathing of the deep seafloor many times, in nodule fields just like this one, with machines just like this one, going back more than 40 years. In the early 1980s, a study measured oxygen on the floor of the North Pacific. The oxygen went down. In the mid-2000s, another team measured it in this very Clarion-Clipperton Zone among the nodules. It went down. Studies in the Peru Basin more than a decade ago did the same. A study just 2 years ago, again in nodule-rich Pacific seafloor, found the same thing once more. 5 separate teams, different decades, different ships, different stretches of the Pacific, some of them working in fields thick with the very nodules now under suspicion, and not one of them, across more than 40 years of looking, had ever watched the oxygen climb. Every one of them measured the deep sea consuming oxygen, quietly, steadily, at rates that all sat close to the same gentle global average. The line went down. It always went down. One study, and only one, found it going up. There is a quiet principle in science for exactly this situation. It is sometimes called Twyman's Law, and it states something humbling. The more remarkable and exciting a result is, the more likely it is to be the product of some error. It is not cynicism. It is hard-won experience. When a single measurement breaks sharply away from a mountain of careful work that all agrees, the safe first assumption is not that the universe has changed its rules. It is that something, somewhere in the apparatus, went wrong. And there was an even deeper problem hiding inside the grandest version of the claim. The team had suggested, at its boldest, that dark oxygen might tell us something about how Earth itself first became breathable, the great event, billions of years ago, when oxygen first filled our air. But that idea folds in on itself. Because oxygen is required to form these nodules in the first place, you cannot build them without it. So they could not possibly have been the thing that first oxygenated a world that had no oxygen yet. They are a product of a breathable planet, not its cause. The chicken cannot lay the egg it hatched from, which leaves us with a strange and very human picture. A single anomalous reading, standing alone against decades of agreement, attached to a mechanism that seemed to break the rules of physics, missing the hydrogen it should have produced, and resting in part on data that had been left out of view. And yet, here is the thing about the deep places of our own planet. They have a long history of hiding oceans we refuse to believe were there, right up until one impossible sample forced us to look again. Consider what happened a few years ago, far from any sea. A scientist paid about $20 for a small, dirty brown diamond dug out of river gravel in Brazil. It was not a beautiful stone. It was almost ugly. But trapped inside it, far too small to see with the naked eye, was a single grain of a blue mineral called ringwoodite, a mineral that can only form under the immense pressure of the deep earth, hundreds of kilometers down. And that tiny grain was wet. It carried water locked inside its structure. And from that one flaw in one cheap diamond came the first direct physical evidence for something scientists had argued about for half a century, that there may be a vast hidden reservoir of water bound inside the rock of the planet's mantle, somewhere between 400 and 660 kilometers beneath our feet. Possibly as much as 3 times all the water in all the world's oceans, sealed inside stone where no one had ever been able to look. The mineral even carries a name from this same kind of patient, stubborn work. It was named for an Australian scientist who spent his career figuring out how the ordinary rocks of the upper earth transform under pressures we can barely reach. In its pure laboratory form, it is a startling, deep blue. And the way it was finally confirmed in nature fits this story exactly. Scientists watched the shudder of distant earthquakes travel through the planet, and they noticed the waves slowing down as they crossed one particular deep layer, as if they were passing through something wet. The water cycle, it turns out, does not stop at the shoreline. It reaches down through the crust, riding the slow grind of ocean plates sinking into the mantle, carrying the sea itself into the rock of the deep earth. Think about what that means. 3 times the water of every ocean on the surface, hidden the entire time because it was locked inside stone in a place we had no way to reach. It took a flaw buried in a worthless-looking diamond thrown up to the surface by a violent ancient eruption to prove it was there at all. The lesson is not subtle. Our planet is far less explored than it feels. The ground beneath your feet and the seafloor beneath the waves are still full of things we have not yet found, and a few of them are large enough to rewrite the story of the whole world. An ocean's worth of water, 3 times over, hiding in the dark below, found because one person decided not to throw away an ugly little rock. The deep, it turns out, keeps its secrets well, and it does not give them up to the people who look away. So where does that leave the dark oxygen of the Clarion-Clipperton Zone? By every ordinary measure, the story should be over. The mechanism has been challenged on physics. The numbers have been challenged on the data. The authors have walked back their 2 central claims. The funding company has disowned the work. Independent scientists have called for the paper to be pulled entirely, and the journal has flagged it for review. The weight of the evidence, decades of it, sits firmly on the side of a simpler, quieter, less wonderful explanation. That the machine, somehow, made its own oxygen. That the line went the wrong way not because the seafloor came alive, but because of a bubble of trapped air, or a flaw in the box, or some small mechanical ghost we have not fully named. That is, most likely, what happened. But notice the word, likely. Science does not deal in certainty. It deals in the best available explanation, held only until something better arrives. And the careful, honest position today is not that dark oxygen has been disproven outright. It is that the evidence offered for it does not hold, that the simpler explanation fits far better, and that no one else has been able to reproduce the result. That is a very long way from proof of a new force humming at the bottom of the sea, but it is not, quite, the same thing as the door being shut. Because the man who started all of this did not walk away, instead, he went back. With new funding from a foundation in Japan, the team built a fresh generation of machines, landers, designed not for the gentle abyssal plain, but for the very bottom of the world. Instruments rated to descend 11 kilometers, built to withstand more than 1,000 times the pressure at the surface. Machines that, by the team's own description, look less like ocean equipment and more like something you would send into space. They fitted these landers with sensors built for one purpose: to measure, cleanly and beyond argument, whether the seafloor breathes oxygen in or breathes it out. And earlier this year, They set out from San Diego, sailed back to that same dark plain in the Pacific, and lowered their new instruments into the place where the line first went the wrong way. As this is being told, that answer is not yet in. The kind of certainty they are chasing takes months of painstaking work, first on the ship and then back on dry land, before anyone can say what the ocean told them this time. He has not been quiet about the criticism, either. To the suggestion that his oxygen was nothing more than air bubbles trapped inside the instrument, he has pushed back hard, pointing out that his team has deployed these machines for around 20 years, and that in all that time, he says, they had never once seen such bubbles, and had run tests specifically to rule them out. Others remain unconvinced. One scientist, whose own work in these very waters showed no hint of oxygen coming from the nodules, noted simply that the two teams had agreed to sail together to put their methods side by side, on the same water, with the same instruments, and watch the line, which may, in the end, be the only way a thing like this is ever truly settled, not by argument, by going back down together and looking. So we wait. And while we wait, it is worth remembering where this all sits, not at the edge of the known universe, not on some distant moon, but at the bottom of our own ocean, the part of our own planet we understand the least. We have seen less than 1/1000th of 1% of the deep seafloor. We have mapped, in real detail, less than a third of it. There are creatures down there that have adapted, cell by cell, to a darkness and a pressure that would crush us instantly, animals that grow special molecules just to keep their own bodies from being squeezed apart, living in a place where the water never sees the sun and never will. We have given that place the name of the underworld, and we mean it almost literally. It is the nearest thing to another planet that exists anywhere within reach of us, and we have barely set foot in it. The same darkness we are now designing robots to one day pour beneath the ice of Europa is sitting, right now, a few kilometers beneath the keel of an ordinary ship. We have built machines that imploded trying to reach it. We have named its deepest trenches after the underworld. We send landers down to crash land on its floor and listen the very same word, the very same act we will one day use on the floor of an alien sea. This is the quiet truth underneath the whole strange affair. The argument over dark oxygen was never really only about a faulty sensor, or a missing control, or a voltage too small to split water. It was about how thin the edge of our knowledge truly is. About how, 4 kilometers beneath a calm grey sea, on a plain of metal stones that took 10 million years to grow, we can lower a machine into the dark and pull up a reading that nobody, not the textbooks, not the experts, not even the people who built the instrument, can fully explain. Maybe it was a bubble of air, maybe it was nothing at all, or maybe, somewhere down there in the cold and the black, the floor of the world is doing something we have not yet earned the right to understand. We sent our machines to the bottom of the ocean to learn how life might survive on the lightless seas of other worlds. We did not expect the bottom of our own ocean to start whispering back an answer we couldn't read. And for now, that is exactly where we stand, leaning over a glowing screen in the middle of the Pacific, holding a light that reaches only a few feet into the dark, waiting for a planet we have barely begun to explore to decide whether it will tell us the truth.